Hello and welcome to our lecture presentation on Chapter 9. In this video, we will be introducing you to what we call hypothesis testing. Hypothesis testing is a very popular and very important concept to discuss in statistics. Basically, what we are going to do with hypothesis testing is we are going to consider different existing theories or existing claims, and our goal will be to provide evidence against or evidence in support of these existing claims. And so, by way of introduction, we will define hypothesis testing, and then we will go through the five-step process on hypothesis testing. We will look at different scenarios of hypothesis testing. The first being the case where the population standard deviation is known. And then we'll look at cases where we do not know the population standard deviation. And then we'll look at hypothesis testing for proportional distributions. Then we'll close off our discussion on type 1 and type 2 errors. And so let's look at the five-step process on how to perform a hypothesis test. You see, in most cases in statistics, what we are mostly concerned about is there an existing statement? Is there an existing theory? And our goal is to prove whether or not there are evidence supporting that existing theory. And so hypothesis testing basically look at a claim that is currently believed, and our duty will be to perform a test to either confirm the claim is right or the claim is wrong. Now, take for example, there are certain claims that we have all grown to accept, but statistically, there are no evidence to support that. The first could be the claim that if you want to live healthy, drink 8 glasses of water. It is believed that the average healthy person drinks 8 glasses of water. But has there been a statistical test of hypothesis to prove whether or not this assumption is true? Or think about the assumption that uh, the average healthy person walks or takes 10,000 steps a day. So most of the times we walk and we count our steps to make sure we hit that 10,000 mark. And when we are able to make that 10,000 mark, we become happy because we assume that to be the number of steps you need to take to be healthy. But then the big question is, has there been a hypothesis test to prove or to disprove that? And so in hypothesis testing, what we are going to do is we're going to look at a five-step process where we will consider the existing claim, and then we'll look at evidence against the existing claim. We will be looking at different distributions for our hypothesis test. We'll start with a Z distribution where the population standard deviation is known. And then we'll look at a T distribution where the population standard deviation is unknown. And then we'll consider a proportional distribution case of hypothesis testing. Now, the first step in the hypothesis test is to state what we call the null and alternative hypothesis. Stating the null and alternative hypothesis is very foundational to hypothesis testing. What you want to do is you want to state the current assumption. The null hypothesis basically is what we currently believe, the theory that we have come to accept and therefore needs to be challenged, the belief or the statement about a population that we have come to accept. In most cases, this is how we write the null hypothesis. So let's look at an example of how we state the null hypothesis as step 1 in our hypothesis test. Most of the times, what we would say is this null hypothesis, which is the statement that we hope to disprove or the statement that we want to challenge, is such that we currently believe that the average number of glasses a healthy person takes is equal to 8 glasses of water. And so this is how we state the null and alternative hypothesis. In this example, our null hypothesis, our current claim or theory is that the average number of glasses you should take should be 8 glasses of water. Let's look at it in the context of the steps. It's the exact same thing. Our null hypothesis, HO, is that the average number of steps, so we use the population average, right? We always use the population average. The average number of steps for a population of healthy people should be 1,000 steps. And so the null hypothesis basically is the current claim or the current theory. Our goal in hypothesis testing is to find evidence against this. If we do not find any evidence against it, then it means we have to accept it. But if we are able to find evidence against it, then we will reject it. And so the whole goal is to see if there are evidence against this, and if there are evidence, we reject the claim. If there are no evidence, we accept the claim. So our first step in a hypothesis test, step 1, is to state the null hypothesis. Now, another thing we also do in step 1 is to state what we call the alternative hypothesis. The alternative hypothesis is our research statement. Is the statement we hope to be true. The alternative hypothesis is a statement that goes against the null hypothesis. It is always the opposite of the null hypothesis. The alternative hypothesis is a statement we hope to find evidence in support of. And so the existing claim could be, for example, the average number of steps a healthy person takes is 1,000 steps. As an alternative hypothesis, which is a statement we hope to be true, a statement that goes to challenge the existing claim, our alternative hypothesis will be that the average number of steps a healthy person takes is not equal to 1,000. And so we hope that the null hypothesis will be false. We hope to reject the null hypothesis. And to be able to find evidence against the null hypothesis, we have to state the alternative hypothesis. We denote the alternative hypothesis as HA, right? Hypothesis alternative. And so we always start our hypothesis test process by stating the null and the alternative hypothesis. And our goal is to find evidence against the null hypothesis so we could accept the alternative hypothesis. Now, the general form of writing our null and alternative hypothesis in this course is such that if the null hypothesis is that the average is greater than a specific number, our alternative will be that the average is less than a specific number. And so the alternative hypothesis is always a statement opposite to the null hypothesis. If the null hypothesis is that it's less or equal to a number, our alternative hypothesis will be that it's greater than a number. If the null hypothesis is equal to a number, our alternative will be that it's not equal to a number. Now, when you consider these two null and alternative hypothesis statements that we have here, we call them one-tailed hypothesis test. The reason is if the alternative hypothesis for a null hypothesis like this is less than, then it means on a standard normal curve, we are looking at only one side of the curve, which is less than. So it means we are looking at this side. If the alternative hypothesis is looking at a greater than, sign, then it means it's also another one-tailed test where we are looking at the upper side of the curve because we are looking at the greater than sign, and so that means we are looking at the one-tailed side of the curve. Now think about this and tell me, what do you think about this alternative hypothesis here? And why do you think we call it a two-tailed alternative hypothesis? It's two-tailed because we are looking at the possibility that our average of the population is not equal to a specific number, which means it could be greater than a specific number or less than. And so this is called a two-tailed test because we are looking at the two-side part of the curve, right? When we say it is not equal to a number, that means it could be less than the number or it could be greater than the number. But let's practice a little bit on how to state an alternative hypothesis. I'm going to do the first one for you. I would like you to spend some time and practice on the second one. When we get a chance to meet, we will be looking at how to state an alternative hypothesis using this as a practice test. The null hypothesis. So consider each of the following statement and state the null and alternative hypothesis. The average student owes at least $75,000 in student loan. The null hypothesis HO is stating that on an average, a student will owe at least $75,000. What does it mean? It means that our null hypothesis is stating that the average student will owe about 75,000 or more. I'm just gonna shorten it here and say 75K, right? The alternative hypothesis, on the other hand, will be what? If the null hypothesis is saying the average will be greater than or equal to 75K, then opposite of that will be that it will be less than 75K, right? And so the alternative hypothesis will always be a statement opposite the null hypothesis. If the null hypothesis is greater than or equal to, the alternative hypothesis will be the other side, which is less than. I'll spend some time on this, but after we state the null and alternative hypothesis, which is what we do in step one, the next thing we do is to specify the significance level. In an actual real life test, you as a researcher have to choose your significance level. But in the case of a classroom exam or a classroom test, the significance level will be given to you on the test. The significance level basically is a probability value. It's the level at which we decide whether there is enough evidence to reject the null hypothesis or we fail to reject it. The reason we stated before is just so we will prevent a p-value high. But the significance level sort of help us to know the benchmark at which we will decide if there is enough evidence or we do not have enough evidence. And so when we develop our null and alternative hypothesis, the next thing we do is to develop a benchmark. Now, like I said, this level of significance is always given to you in a question, and in most cases, the level of significance we work with is the value 0.05. Okay, my computer is not helping me here, but we usually work with a value 0.05, and that's what we usually use as our significance level. And so what that means is when we find evidence to support the null hypothesis, and the probability of that evidence is less than this 0.05, then it means we have to reject the null hypothesis. But if our evidence is greater than this benchmark of 0.05, then it means we don't have enough evidence to reject the null hypothesis, but it means we have to accept it. Now, the next thing we're going to do is Once we state the null and alternative hypothesis, and then we create our benchmark at which we decide to either accept or reject the null hypothesis, the next thing we do in real life statistical research is we will go out there and collect sample data to know if our sample data matches the null hypothesis. And so we do that by calculating what we call the z-test value. The z-test value basically is a formula most of you are familiar with based on our discussion on chapter 7. Is the x bar value minus the population average divided by the standard deviation of the population over square root of our sample size n. What this z value basically is doing is it's going to measure how compatible our sample average is to the population average, taking into consideration the effect of the standard deviation and the sample size. If our sample average is close to the population average, then that means there is not much of a difference between these two. But if we see a huge difference between our sample average and the population average, then it means we don't really see a lot of evidence to support the null hypothesis, and that's going to lead us to a rejection of the null hypothesis. What am I trying to say? Basically, our null hypothesis gave us the notion that, or the claim that the average of the population is a certain number. We don't believe that, and that's why we created the alternative hypothesis. This value here is going to tell us how our own research average is closer to the population average. If our research average is so far away from the population average, then it means we don't really believe what the population average is to be true, and therefore we will reject the null hypothesis. But if the difference between these two is so small that it's practically the same, then it means that we actually will have to accept the null hypothesis. And so this z value here is going to measure how far these two numbers are away from each other. If they are close, the z value will be smaller. If they are wide apart, the z value will be bigger. And when the z value is really big, it usually leads us to reject the null hypothesis. But we'll get to see that in real life. And so once we find a z value, the next thing we do is to calculate what we call the p-value. This p-value here is the probability of us not rejecting the null hypothesis, assuming the null hypothesis is actually true. And so we calculate the p-value to give us the probability of not rejecting the null hypothesis. And then the last thing we will do is we will compare our p-value to the significance level. If the p-value is greater than the significance level, then we accept the null hypothesis. If the p-value is less than the significance level, then it means we need to reject the null hypothesis. Let's look at the whole process using a specific example. So this is going to be a one-tailed test in a case where the population standard deviation is known. Let's work on this example together. So the response time for a random sample of 40 medical emergencies were tabulated. The sample mean is 13.25 minutes.